Thank you for your interest in SchedulePro. SchedulePro is a versatile production planning, scheduling, and resource management tool designed specifically for the batch process manufacturing industries. This video will provide you with a clear picture of the features, capabilities, and benefits of SchedulePro. SchedulePro and SuperPro Designer are complementary products in IntelliGen's suite of process modeling and optimization tools. SuperPro Designer is focused on detailed analysis and evaluation of single batch processes, whereas SchedulePro handles modeling, scheduling, and debottlenecking of multi-product facilities. The recipes of batch processes modeled in SuperPro Designer can be exported to a recipe database and then imported into SchedulePro for subsequent editing and analysis. Alternatively, recipes can be developed directly in SchedulePro. Note that SchedulePro plays a dual role. First, it extends SuperPro's capabilities for process modeling, capacity analysis, and optimization to multi-product facilities. And second, SchedulePro handles production planning and scheduling of these facilities on an ongoing basis. This video will describe both of these roles in detail. First, let's start with a brief overview of SchedulePro. SchedulePro is a finite capacity scheduling tool for batch and semi-continuous manufacturing processes. Typical applications of SchedulePro include production planning and scheduling on an ongoing basis, plant debottlenecking, cycle time reduction, and capacity analysis and throughput increase. SchedulePro handles biochemical, pharmaceutical, fine chemical, consumer product, food, and any other type of batch manufacturing process. In addition, SchedulePro was designed to be consistent with Windows standard functionality, and it features an intuitive user interface. Furthermore, it is a recipe-based tool that does not require any programming skills. As a result, SchedulePro is easy to learn and use. Let's take a closer look at SchedulePro now. SchedulePro uses an intuitive recipe-based representation of a manufacturing process. A SchedulePro project can contain any number of recipes, each describing the production process for a particular product. A recipe can be divided into sections, as you can see here. Similarly, each section is divided into procedures. And finally, each procedure contains one or more operations. Each of these operations is initialized by the user in order to capture any important information such as the operation name, duration, scheduling sequence, auxiliary equipment, etc. The level of detail that is provided for each operation is completely up to the user. Therefore, if you are only interested in equipment scheduling, you can focus on the tabs that matter to you, such as the scheduling and duration tabs, while ignoring tabs that are not necessary for your purpose, such as the ones for labor requirements, utility usage, or raw materials. This allows you to create basic models in SchedulePro very quickly and easily, but it also provides you with more advanced capabilities in case you do need to take other constraints into account. The procedures and operations within a recipe utilize resources within facilities. These resources can include labor, staff, utilities, equipment, work areas, transfer panels, storage units, and material supply systems. The user can specify outages of resources as a function of time to account for things like planned equipment maintenance, holidays, weekends, etc. Once resources have been defined and a recipe has been created, the process schedule can be viewed and analyzed. A great way to view the details of the process recipe and ensure the scheduling of your operations is correct is to visit the Recipe Gantt chart. This chart shows the durations as well as the start and end times for each operation within a recipe. This allows schedulers to visualize the recipe before campaigns are scheduled. Furthermore, using this chart, it is easy to see synchronization of operations that take place simultaneously. For instance, the transfer to DE filter operation in procedure P1 takes place at the same time as the filter operation in procedure P2. Links such as this one between two different operations are established during the creation of the recipe. Note that the recipe information can also be edited directly through this chart by simply double-clicking any operation that you want to modify. SchedulePro also provides additional recipe views which allow you to quickly specify all the labor information, stream information associated with the recipe, etc. After the recipes have been checked to ensure that they are correct, campaigns of various recipes can be scheduled through the Production Schedule view. Here you can specify the required number of batches in a campaign, or the total desired quantity of product. You can also specify the start time of a campaign, based on the calendar, or based on the timing of other campaigns. In addition, there are advanced options for specifying things like campaign cycle times, as well as changeover times and other scheduling preferences. Once the campaigns are scheduled, the equipment occupancy chart can be generated in order to view the utilization of each equipment item. In this example, the graph is showing a 4-week production schedule with 2 campaigns. A campaign is a set of batches of a given recipe. Note that the style of this chart is highly customizable. For instance, the colors of each individual batch can be changed by double-clicking on them in the legend on the right. Or the color scheme could be set up so that each campaign has a specific color. Here, the blue bars at the top represent a campaign of 6 batches of the Protein 1 recipe. The green bars at the bottom represent a campaign of 5 batches of Protein 2. The 2 products are run on dedicated equipment trains or lines, which are designated here as L1 and L2. If desired, equipment can also be shared between production lines. For instance, this facility has shared CIP skids that may be used by either line. Both lines in this example also share resources such as labor, utilities, and materials. Multi-batch campaigns can be scheduled based on their minimum batch cycle time or based on a larger cycle time with slack time between batches. In this example, there are approximately 12 hours of slack time between batches, which allows the plant to absorb some process variability. Note that the upstream suites in this example run 24 hours a day, 7 days a week. However, the purification suites, which include equipment such as diafilter DF2, column C2, etc., only operate from 8 a.m. until midnight. The downtime in the purification suites is shown by the gray bars on this graph. Notice that some operations in the purification suite actually overlap with the gray bars, meaning that these particular operations may continue to run during the night shift downtime as long as they are started during normal working hours. For instance, this bar represents a diafiltration operation that runs for approximately 30 hours once it is started. The ability to specify that certain operations can be scheduled to start or finish during line downtime is part of the scheduling flexibility that SchedulePro provides. Additional flexibility can be added to the schedule with the use of flexible time shifts. These user-defined shifts allow specific operations to automatically begin earlier or later than their specified start times, based on the availability of equipment, utilities, staff, or other resources. For instance, if a CIP skid is not available for a cleaning operation at a given point in time, that cleaning operation can be automatically shifted by SchedulePro so that it takes place after the CIP skid becomes available. Furthermore, SchedulePro provides the ability to interrupt specific operations and restart them later. These options give you additional flexibility in how you can run your process and allow the software to determine better schedules with less downtime. Note that when an equipment item is idle due to a flexible shift or interruption, the idle time is displayed with a see-through bar such as this one. This means that the equipment does not have an operation that is actively being run in it, but the procedure that utilizes that equipment item is not yet complete. Therefore, this equipment item is not available to be used in other activities yet. Also notice that there are white bars after batch 6 for all the equipment used in the Protein 1 campaign. These white bars represent a 72-hour changeover time that has been specified for the campaign. Changeovers can be manually specified for each individual campaign, or they can be automatically determined based on a user-defined matrix in which changeovers between different types of products have been specified for each equipment item. In addition to equipment scheduling, it may be necessary for you to track resources and inventories of materials. To facilitate this, SchedulePro automatically creates charts showing material inputs, product generation, waste generation, labor requirements, and utility usage over time. For example, this chart shows the demand for operator labor over the course of the schedule. Note that it is possible to specify fractional labor requirements for a given operation, such as a long reaction which may require occasional monitoring, but which does not require constant activity. Another type of resource chart is the raw material usage chart. For example, this particular chart tracks the consumption of water for injection, frequently abbreviated as WFI, over the course of our schedule. Notice that it gives the instantaneous demand, in red, as well as the cumulative and time-averaged demand, in green and blue, over a 12-hour period. The time period can be modified by the user. These types of demand profiles allow you to determine the required capacities of your water purification, storage, and distribution systems. Furthermore, the ability to create resource charts for utilities, labor, and other materials allows you to design adequately sized utility systems, schedule sufficient quantities of staff members during different time periods, effectively determine long-term material requirements and costs, etc. Notice that resource and inventory charts can be linked to the equipment occupancy chart. This allows you to view them simultaneously. In addition to resource charts such as this one, inventory charts can be generated for raw materials, intermediates, products, and waste. For instance, this chart shows the inventory level within the WFI storage tank. The blue line represents the flow of WFI into the tank when the WFI still is active. The green line represents the total volume of material in the tank at any point in time. In this example, the storage tank has been set up to automatically refill at a rate of 3,000 kilograms per hour when the volume in the tank falls below a certain threshold. Inventory charts such as this one allow you to plan raw material purchases, plan production of intermediates and products, and acquire appropriately sized storage units for raw materials, products, and waste. Furthermore, if desired, resources and inventory levels can be set as hard constraints in SchedulePro. This means SchedulePro can automatically identify and resolve conflicts associated with insufficient resources. For example, if there is insufficient WFI available in the WFI inventory tank to meet all scheduled processing needs, SchedulePro can delay appropriate operations in order to ensure the WFI tank doesn't run out of material. Similarly, if there are only 15 operators available in the plant, but the scheduled peak in operator utilization is 18 operators, SchedulePro can automatically delay appropriate operations so the labor constraint is not exceeded. I will now link this inventory chart to the equipment occupancy chart. Notice that after linking the charts, if you zoom into the schedule and scroll to the right or left, you will see the corresponding resource demand for that part of the schedule. Furthermore, any changes that are made to the schedule will show up on all visible charts. As a result, you can easily see the impact of a change in your production schedule on the relevant resources. For example, in the case of the WFI demand and inventory shown here, you can easily determine if your purified water still, storage tank, and distribution loops will be able to meet process demands under various production scenarios. If you would like to learn more about SchedulePro's capabilities for WFI system design, please view the detailed WFI system sizing videos under the training page of our website. When using SchedulePro on an ongoing basis for plant planning and scheduling, it can be useful to save snapshots of your schedule at various points in time. This allows you to compare your planned production schedule to your actual production operations later on. SchedulePro is equipped with a SQL Server database that you can use for storing this historical data. I will take a snapshot of our initial schedule now, so we can compare it to a modified schedule in a few minutes. Now let's say we are several days into our original planned production schedule. This situation can be visualized using the current timeline, shown here as a vertical red line. The current time can be updated either by using the clock feature or by manually dragging the vertical current time bar. Note that the patterns on the equipment activity bars change based on the location of the current time bar. As you can see, a crosshatch pattern is used to indicate completed activities, whereas a pattern of single diagonal lines indicates that an activity is still in progress. In order to make it a little easier to distinguish one batch from another, I will change the color scheme so that each batch within a campaign has a unique color associated with it. Now it is clear when each batch begins and ends in each piece of equipment. Now let's say we have started our production schedule and there is a 1-day delay in the harvesting of the first fermentation batch due to inoculum preparation problems. To account for this, we can change the duration of this operation from 2 days to 3 days. When I click OK, the equipment occupancy chart will change as a result of the delay in this operation. In addition, the resource and inventory charts will be automatically updated to reflect the scheduling changes. As you can see, the demand for WFI shifted as soon as the fermentation operation's duration was changed. Furthermore, by checking the inventory chart, I can see that this change in the schedule does not cause any difficulties with the supply of WFI. The green inventory amount line never approaches 0, meaning that the WFI supply system can still meet all demands from the facility without running dry. This is just one example of how the resource and inventory charts can be used in parallel with the equipment occupancy chart in order to modify the production schedule in a way that will still produce feasible solutions. Furthermore, notice that all the operations that depend on our delayed fermentation operation were rescheduled automatically. Note that SchedulePro does not automatically update the entire schedule, since this could potentially lead to undesirable outcomes. For instance, production of a high-priority product might be delayed unnecessarily. Therefore, as a first step, SchedulePro simply displays conflicts created with future batches. Conflicts are highlighted in SchedulePro by the addition of extra equipment lines labeled with exclamation points, and by changing the outline of each conflicting activity from black to red. At this point, the next logical step is to resolve the conflicts created by the initial delay. To resolve the conflicts between batches 1 and 2, I can right-click on batch 2 and select Batch, Resolve Conflicts for Batch. This will result in resolution of the conflict between the first and second batches. However, notice that a new conflict has been created between the second and third batches. I could resolve this conflict in the same manner as before, or I could manually click and drag this batch in order to give it a later start time. This resolves the conflict between the main equipment in batches 2 and 3, but it also creates new conflicts with the CIP skids. This process of right-clicking to resolve conflicts or manually dragging batches to resolve conflicts could be repeated until all conflicts are eliminated. However, it is also possible to resolve all conflicts associated with the campaign at once, or to resolve all conflicts in the entire schedule at once using this menu. To complete the conflict resolution process for this file, including resolving all CIP skid conflicts, I will select Resolve All Conflicts now. As you can see, this menu provides the quickest and easiest way to resolve complex scheduling conflicts. I will take another snapshot of my process now. Note that rather than simply delaying batches, SchedulePro has other methods for conflict resolution as well. To demonstrate this, I will first close my inventory and resource charts so I can see more of my equipment occupancy chart. Now let's say there's a delay in the first fermentation batch for our second campaign. As a result, the expected duration of this operation will be increased from 3 days to 4 days. As before, you can see a conflict between the first and second batches of this campaign. However, when I click to resolve all conflicts, you can see that rather than delaying the second batch, SchedulePro has simply used a different fermenter for the fermentation procedure in batch 2. SchedulePro's conflict resolution algorithm will do this if you have specified alternative equipment that can be used for a given procedure. This is possible because of SchedulePro's equipment pool concept. An equipment pool is simply a group of equipment items within a facility which may perform the same function. After a pool is created, SchedulePro can automatically choose the appropriate equipment for a process from that pool. This selection is based on the capacity and availability of the equipment items in the pool. As you can see, resolving conflicts is quick and easy with SchedulePro, and the scheduler has a great deal of flexibility regarding how to resolve conflicts that arise. Of course, there are other ways to resolve conflicts over the longer term, such as adding spare equipment to a facility, adding staff in order to reduce or eliminate the designated downtimes, adding storage or utility capacity if required, etc. SchedulePro's resource charts and equipment occupancy chart facilitate these kinds of analyses and allow you to make the most profitable capacity utilization and capacity expansion decisions. Let's say we've moved forward in time again and we would like to add additional campaigns to our schedule. This can be done through the Campaigns menu here. I'm going to choose to add 3 more batches of the Protein 1 recipe, which will begin after my current campaign is complete. First, I will modify the recipe name so it is easier to differentiate from the other campaigns. Then I will set the number of batches to 3. I will schedule my batch to begin shortly after the equipment is freed up from the previous campaign. I will also give each batch a 72-hour cycle time. This completes the campaign setup, although my new campaign will not yet appear on my equipment occupancy chart. Before adding this newly created campaign to my production schedule, I will change the color scheme so it is easy to differentiate the new campaign from the previous ones. If I now click the Schedule Campaigns button, you can see the new campaign. Finally, I will add a small delay to this campaign. I will now take a final snapshot of my production schedule to capture the updates that I have made. At this point, let's take a look at our current schedule compared to our original planned schedule. One way to do that is to simply view the snapshots that I took previously. Here you can see the original schedule. And here you can see the schedule after the first delay was imposed. Another way to view and analyze the differences between our original schedule and a later snapshot is through the Stored Campaigns dialog. Here you can see the start and end times of each campaign, as well as their delays and percent completion. Delays are calculated by comparing the scheduled end time of the final snapshot with the end time of the first snapshot that was taken. Note that for the first 2 campaigns that were scheduled, the overall production schedule was not delayed. This is because there was some slack time between batches to absorb production variabilities. However, the newly added campaign did have a delayed end time because its delay occurred at the very end of the batch. Therefore, this delay could not be absorbed between batches. If slack time had not been added between batches of the first 2 campaigns, their campaign end times would have been delayed as well. It's also possible to generate reports and view delays graphically. In this chart, the green part represents the portion of each campaign that was on time, and the red part represents the portion of the campaign that was delayed. Information related to campaign timing and performance can also be generated in report format. Here you can see the start and end times for each individual batch within this campaign. You can also drill down into the individual procedures associated with the campaign. In addition, it is possible to view these reports through the Internet. As a result, operations personnel don't need to be at a computer with SchedulePro installed on it in order to view the production schedule information. They can view this information from a different site or even from home if they are given remote access. In addition to the various charts we have gone through, SchedulePro generates a variety of reports that summarize the equipment utilization, material usage, economic results, etc. These reports provide additional details about the production plan for managers as well as operations personnel. For instance, the Daily Activity Report shows all the procedures scheduled for a given day. There is much more to SchedulePro than we can cover in this brief introduction. If you would like additional information, please do not hesitate to contact us for a WebEx presentation. You can also download the demo version of the software from the Downloads page of our website and study the examples that come with the application. Furthermore, you can view the SchedulePro tutorial videos posted under the Training section of our website. These tutorial videos provide detailed information on the fundamentals of the application. Thank you very much for your attention and your interest in SchedulePro.